welcome back to my channel. So in this video I'm gonna focus on solving the problem about measurement and uncertainty. So topic 1 of IB physics. So all the problem in this PDF file comes from IB question bank, the 4th edition. So I will post a link of this PDF file in the description part, so feel free to download the file. In this file is many 39 pages, I think, and I will also post a mark scheme of this file as well. A velocity of 5 meters per second can be resolved in perpendicular direction xy and xz. The component of the velocity in the direction fy is of magnitude 4 meters per second. What is the magnitude of the component in the direction xz? So for here, it has a magnitude of 5 meters per second, and xy has a magnitude of 4 meters per second. And we know xy is perpendicular to xz, so you can draw a line that is perpendicular to xy, parallel to xy and perpendicular to xz. Right. And this line has a magnitude of 4 meters per second. Now we just need to solve for xz. So you can just use Pythagorean theorem. So 5 square minus 4 square is equal to 3 square. So xz gotta have a magnitude of 3 meters per second. What is the unit of energy density? So we know energy has a unit of joule, which is equal to kilogram times meter square over second square. So energy density can be equal to joule over area, so which is equal to joule over meter square, or it can be equal to joule over mass, so joule over kilogram, or it can be equal to joule over volume. And we know only option A feed for energy density, so A is a correct option. Which of following express Y in terms of fundamental unit? So Y is the unit for power, which is equal to energy over time. So energy is equal to kg times meter square over second square, divided by time. So and it is also for second. So this is equal to kg times meter square or second cube, right? So the answer is D. Shows a set of experimental results to determine the density of oil. The results have systematic error and random error. Using the information on the graph, what can be said about the measurement to find the density of the oil? So you just need to determine random error and systematic error. So there are little cross on the graph, and here, they all represent the range of uncertainty. And as you can see, the size of the cross is very consistent on the graph, so it must contain a very small random error, right? Because big random error generate a large range of uncertainty, so it cannot be option B or option D. Now you just need to determine systematic error. So I draw a line across all the cross on the graph. So I find that when the oil has a mass of 0 kilogram, it has a volume of something here. So now I know it must contain a very large systematic error, because when you are trying to measure the weight of the oil, here contain a large systematic error. So the answer is C. It contain a large systematic error and a small random error. Which of the following express the unit of capacitance in terms of foundational unit? So this one is a little bit tricky. tricky. So we know capacitance is equal to charge over voltage, right? And voltage has a unit of coulomb, and voltage has a unit of volt. So charge is equal to current times time. You need to do this because charge has a SI unit of coulomb, but its base unit is not coulomb. So ampere has a SI unit of ampere. Time has a SI unit of second, so it's equal to ampere times second, right? And voltage here, voltage is equal to energy over charge, so joule over charge, and joule has the SI unit of kilogram times meter square over second square over charge has the SI unit of coulomb, so AS, and this is equal to kilogram times meter square over ampere times second cube, right? Now you can calculate SI base unit. So coulomb is ampere times second divided by voltage. So you time the reciprocal of this quantity. And this is equal to ampere squared times second to its fourth power 1 over kilogram times meter square. So this is A. So let me erase this. Right. And this is equal to ampere squared times second to the fourth power times kilogram to negative 1th power, and meter 2 is negative twice power. So the answer is A. Here was is measured with an uncertainty of 2%. What is the uncertainty in the volume of the sphere? You know, volume of the sphere is calculated by the formula of 4 over 3 times pi times r squared, where r cubed, where r is the radius. And to calculate the uncertainty of this quantity, you just add up all fractional uncertainty. So r cubed can be seen as r times r times r. And each r has a fractional uncertainty of 2%. So you just add up them together and you have a fractional uncertainty of 6%. So the answer is C. The force of air resistance F that acts on a car moving at a speed v is given by F is equal to kv squared, where k is a constant. What is the unit of k? So force has a unit of Newton, which is equal to kilogram times meter per second square. And velocity has a unit of meter square per second square. Right? So Newton kilogram times meter per second square must be equal to the unit of k times meter square per second square. So the SI base unit of k can be calculated by the meter square over second square on the both sides. And then you should get an answer of kg times meter over second square times the reciprocal of this quantity. And second square cancels out. Here cancels out. This is equal to kilogram over meter. Right? So A is the correct option. The volume V of a cylinder of radius r and height h is given by V is equal to pi r squared times h. The volume of the uncertainty was measured with uncertainty of 10%. And the height was measured with uncertainty of 6%. What is the uncertainty in the radius of the cylinder? So you want to calculate R, right? And we know the formula. Volume is equal to pi r squared times h. So V over h and divided pi on both sides, take the square root, must be equal to r, right? So for r over h pi has a fractional uncertainty of y. So 6% times 10%, 16%. And then you take the square root of something, and then the uncertainty gotta be divided by 2. So radius must have a uncertainty of 8%. So D is the correct option. So I will just for division or multiplication, always add up the fractional uncertainty. But for square root, I don't know, let's say 8%. Then the quantity, the uncertainty of this quantity is a half times n%. So which of the following is a unit of energy? We have done this problem before. So take the formula of kinetic energy, kilogram times meter over second square. Right. So where is the, so C is the correct, meter square, so here is meter square over second square. So B is a correct option. Which of the following is a fundamental unit? So ampere is a fundamental unit. So Coulomb C is equal to ampere times second. Ohm is also not a fundamental unit. Same thing with volt. They all have their own fundamental unit. The resistive force F acting on a sphere of radius r traveling with speed v through a liquid is given by the equation, where viscosity is a constant. What is the SI unit of viscosity? So we know force has a unit of Newton, which is equal to kilogram times meter over second square, and this is equal to the SI unit of the viscosity times radius, so meter times the SI unit of velocity, so meter over second. So the SI unit of the viscosity must be equal to kg times meter over second square times the reciprocal of this quantity, so meter square over second, and this is equal to kg, kilogram over meter times second. So C must be the correct option. A small object is attached to a string and rotated in a circle of a constant radius in the horizontal plane. The tension T in the string is measured for a different speed v. Which of the following plots should give a string line graph? So a ball, here is a ball. So the object, here is the string. And it's rotated in a horizontal plane and receive a tension T. So let me redraw this picture. So T in this case is the contributive force, which is equal to mv squared over r. So which of the following should give a straight line graph? So I'm gonna change this equation a little bit. I'm gonna do this. Right, so now this look a little bit more clear. So for T squared, it's gonna be equal to mv squared or over v squared. Oh, sorry. Okay, so now this is a little bit more clear. So for this one, let's say I'm gonna write this v squared is equal to x, then the equation become mv over x, and this part can seen as the slope of the function, and x is equal to the input, and this is gonna give us a linear relationship, right? So we know C must be the correct option. If you only draw the picture of t versus v, is not gonna be a linear relationship. It's gonna be a quadratic function. So see this part as a input and see v squared as a whole. I mean see m over v as the slope and see v squared as say whole as the input. So v squared as a whole is the input and m over v is a constant, which is the slope of this function. The vector diagram shows two forces acting on a point object O. The forces are in the plane of the page. Another 5 Newton force is applied on O in the plane of the page. Which of the following gives the direction of the force? Ensure that O is in equilibrium. So the net force gotta be equal to 0. So here is they say Newton force, and here is a 4 Newton force, right? So here this line is gonna give us a net force of 5 Newton. In order to be in equilibrium, the net force gotta be equal to 0, meaning that a force gotta cancel this force, and this force needs to be in the same direction with the net force. So here you need to have a net force. Here you need to have a force of Newton for the object to be in equilibrium. So it must be B. The graph shows the relationship between two quantities P and Q. The gradient of the function is R, and the intersect on the P is Y. So the intersect on the p-axis is here, and here Q is equal to 0. Right? And we know the gradient and the intersect. So quantity P and Q, P will be the output, and Q is the input times the gradient here, and then plus the intersect. So here will be the equation, which is SQ times R. This is not correct. RQ times plus S. This is correct. So C will be the correct option. Aiming the center of the target, the arch fires arrow which produce a pattern of heat as shown below. The pattern suggests the presence of, so center is here and target is here, right? And you need to determine the random arrow and the systematic arrow. So because if the systematic error is consistent throughout a lab, and random error generate a pretty large range of uncertainty here. So here we can see this is the target and this is the center. So it is not very accurate, and it's away from the center. So it has a large range of uncertainty. So here it has some random error, and because at the point where the archer hits is also not consistent, so it also have random error. I mean systematic error. So this pattern suggests both random error and systematic error. The saturation of free fall G is determined by the relationship of G is equal to 4 pi square times L over T square. The uncertainty of L is 2%, and the uncertainty of the volume of T is 5%. What's the uncertainty of G? So G is equal to 4 pi square times L over T square, and T has uncertainty of 5%. L has uncertainty of 2%. So just add up all the uncertainty together. So T square gonna have uncertainty of 10%, and L has uncertainty of 2%. So G will has a uncertainty of 12%. What is the SI unit of momento? Momento is equal to m times v, which is equal to kilogram times meter per second. So this is equal to kilogram times meter times I s to the -1's power. So C is the correct option. Which of the following is a fundamental unit? Ampere is a fundamental unit. Volt, joule, they're all not fundamental unit. They all have their own SI base unit. What is the order of amplitude of the mass in kilogram of a apple? So it will be A, right? Because 1 kilogram is equal to 1,000 gram, and 10 to the negative third power kilogram will be equal to 1 kilogram. 10 to the negative 1's power. So 1 over 10 is gonna be 100 gram. Oops, sorry. Here the answer is actually B, right? So B is a correct answer. So apple has a mass of 100 gram. The diagram below shows the force acting on a block of weight W as it slides down a slope. The angle between the slope and the horizontal is theta. The normal reaction force on the block from the slope is N, and frictional is negligible. Which of the following give the resultant force on the block? So weight is equal to mg, normal force N, and then you can also separate weight into different components. So W sine theta is this one, and here's gonna be, oops, sorry. Here is gonna be W cosine theta, and here's gonna be W sine theta. And the normal force is gonna be equal to W cosine theta, and then here's gonna be a force that point in this direction and has a magnitude of W sine theta, right? So the answer for this problem will be A. Which of the following will reduce random error in an experiment? Using an instrument having greater precision, this will only reduce systematic error. Checking collaboration of the instrument used, this will also reduce systematic error. C, checking zero error on the instrument used, same thing, reduce systematic error. Repeating reading, this is gonna reduce random error. So D is the correct option. A object slides down on an inclined plane that makes angle theta with the horizontal. The weight of the object is W. Which of the following is the magnitude of the component of the weight that is parallel to the plane? So here is W, here is N, here it's gonna be W cosine theta, and here is gonna be W sine theta. So A will be the correct answer, W sine theta. When you have a plane, the parallel force will be always equal to W sine theta. And W is equal to mg. A ball is thrown with velocity u at an angle of 50 degrees above the horizontal. Which of the following is true for the which of the following is the magnitude of the horizontal component of the velocity? So here is u, here is 55 degrees. So here the horizontal force is gonna be u cosine 50 degrees. And the vertical force is gonna be u sine 50 degrees. So the horizontal component is u cosine 55 degrees. So A will be the correct answer. A body accelerates from rest with a uniform acceleration a for a time t. The uncertainty in a is 8%, and the uncertainty in t is 4%. The uncertainty of the speed is what? So just add up all the fractional uncertainty together. 8% plus 4% is equal to 12%. So B is the answer. Which of the following contains one fundamental and one derived unit? So ampere is a fundamental unit. Kilogram is also a fundamental unit. Ampere is a fundamental unit. Coulomb is a derived unit. So B is the correct option. So for C, Joule and Newton, they are both derived unit. D, Joule and Coulomb, they are all derived unit. Current go through a resistor is measured with digital ammeter to be 0.1 ampere. The uncertainty of calculate volume of I square will be what? So to calculate the uncertainty of I square, you just add up the uncertainty of I. So you know the reading is 0.10 ampere, right? And it has two significant figures. So the least significant or the doubtful digit is a rightmost digit, which is 0 in this case, and it occurs at the hundredth place. And this digit corresponds to the I's estimation within the smallest subdivision, which is 0.01. So this is the smallest subdivision, and this is also the uncertainty of current, right? So 0.01 divided by 0.10 is equal to 10%. So the total uncertainty will be 20%. Which of following list two scalar quantities? So EMF is a scalar quantity, momentum is vector quantity, weight is a vector quantity, impulse is also a vector quantity, kinetic energy is scalar quantity, temperature is also a scalar quantity. So D will be the correct answer. A stone is attached to a string when moving in a horizontal circle. The constant B of stone is V. The diagram below shows the stone in two different positions, X and Y. Which of the following shows the direction of the change of velocity? Shows the direction of the change of velocity when moving from X to Y position. So we know change in velocity is equal to VF minus VI. So in this case is equal to, so here is VF, right? VF minus, this is the direction of VI. Right, so it's equal to this arrow minus, I'll put parenthesis here, this arrow. Right? So if you do this, it will get C, but this is not correct because this is plus, this is addition. So in order to do this, you need to reverse direction of this one. So the answer will be D. So another way to think about the picture here is the following. So VF minus VI, right? Can be equal to VF plus negative VI. So plus negative VI is equal to plus this arrow. So negative VI, you just simply reverse the direction here. Sorry, VI is downward arrow. So it becomes this one, negative VI. And that's why D is the correct answer. And this will be the end of the video for IB Physics measurement uncertainty. So this video mainly focus on multiple choice of paper 1 problem. In the next video, I will do all the free response of paper 2 and paper 3 question. So thank you for watching this video, and if you want this PDF file, go to the description part. I will post the link of this file and the mark scheme as well.